How long does it take to build a high-rise apartment building? 2 years? 3 years? Maybe even longer once delays, weather, labor shortages, and supply chain problems begin to pile up. For more than a century, construction has followed the same basic formula. Workers arrive on site, foundations are poured, steel rises floor by floor, concrete cures, utilities are installed, finishing work begins, and only after months or years does a building finally open. But in China, one company decided to challenge that entire process. Instead of building structures piece by piece on a construction site, engineers began manufacturing buildings inside factories. Entire rooms arrived with walls, windows, plumbing, wiring, and ventilation systems already installed. Cranes then stacked those rooms together like giant Lego blocks. The result was something that seemed impossible. A 10-story apartment building assembled in just 28 hours and 45 minutes, a 26-story residential tower completed in 5 days, and a 57-story skyscraper erected in only 19 days. Supporters call it the future of construction. Critics call it a carefully staged engineering demonstration. So what is really happening here? Has China discovered a revolutionary way to build cities? Or is the reality far more complicated than the headlines suggest? Today, we explore how engineers are moving construction from muddy job sites into giant factories, and why that shift could change the future of cities around the world. At first glance, modular construction appears to be a brand new idea. In reality, the concept has existed for decades. After the Second World War, many countries faced severe housing shortages. Governments in Eastern Europe, the Soviet Union, and parts of Western Europe began using prefabricated construction systems to build large numbers of apartments quickly. Entire wall sections were manufactured elsewhere and transported to construction sites for assembly. The strategy worked. Millions of homes were built, but many of those projects also became associated with repetitive architecture, poor quality control, and uninspiring urban environments. As a result, prefabricated construction gradually developed a mixed reputation. Yet, while many countries continued relying on traditional building methods, China faced a new challenge. Urbanization was occurring at an unprecedented scale. Hundreds of millions of people were moving into cities. Demand for housing, offices, hospitals, and infrastructure exploded. Developers needed faster ways to build. At the same time, construction sites remained highly dependent on large workforces, complicated logistics, and unpredictable weather conditions. Every delay increased costs. Every mistake required expensive corrections. Every project faced risks that were difficult to control. Then another event changed the conversation. In 2008, a devastating earthquake struck Sichuan province. Thousands of buildings collapsed. Entire neighborhoods were reduced to rubble. The disaster triggered difficult questions about structural resilience and construction methods. Among those watching was entrepreneur Zhang Yue. Interestingly, Zhang Yue was not a construction engineer. He was known for building one of China's largest air conditioning and HVAC companies. But after witnessing the destruction caused by the earthquake, he became increasingly interested in how buildings were designed and constructed. He began asking a simple question: why are buildings still assembled outdoors using methods that have changed relatively little for generations? Factories manufacture airplanes. Factories manufacture automobiles. Factories manufacture electronics. Why not buildings? That question eventually led to one of the most ambitious modular construction experiments in modern history. Instead of treating buildings as one-time construction projects, Zhang Yue's company envisioned them as manufactured products. The goal was not simply to build faster. The goal was to industrialize construction itself, and that idea would eventually attract worldwide attention.
The most radical part of the system is not what happens at the construction site. It is what happens before construction even begins. Inside enormous factories, engineers divide buildings into hundreds of individual modules. Each module functions almost like a completed room. Walls are installed, windows are fitted, electrical wiring is integrated, plumbing systems are connected, ventilation ducts are assembled. Interior components are prepared long before the modules ever leave the factory. In traditional construction, many of these activities occur sequentially. One team finishes before another begins. A delay in one area often affects the entire project. Inside a factory environment, however, multiple processes can occur simultaneously. Modules move through production lines much like products in a manufacturing facility. Quality inspections occur continuously. Measurements can be verified repeatedly. Environmental conditions remain controlled. As a result, many sources of delay are significantly reduced. Once the modules are complete, transportation becomes the next challenge. Each unit must be delivered to the construction site in a carefully planned sequence. The order matters. If the wrong module arrives at the wrong time, assembly can slow dramatically. Engineers therefore coordinate manufacturing schedules, transportation routes, crane operations, and installation teams with extraordinary precision. When the modules arrive, giant cranes begin lifting them into position. Workers guide each section into place. Steel connections lock modules together. Structural systems are aligned, mechanical systems are connected, and floor by floor, the building begins to rise. What makes the process remarkable is its simplicity. Instead of creating rooms after the structure is built, the rooms already exist before assembly begins. The construction site becomes an assembly site. This approach gained international attention when Broad Group demonstrated a 10-story apartment building assembled in just 28 hours and 45 minutes. Videos of the project quickly spread across the internet. Many viewers assumed the building had been created from nothing in slightly more than a day. The reality was different. Months of manufacturing preparation had already occurred inside the factory. The foundation had already been completed. Engineering work had already been finalized. Yet even with those qualifications, the assembly speed remained extraordinary. The company then pursued an even larger challenge, Mini Sky City. Standing approximately 200 meters tall, the structure contains offices, residential spaces, and commercial facilities. Traditional construction might require years to complete a building of that scale. Using modular techniques, assembly occurred in just 19 days. For the construction industry, the demonstration was impossible to ignore. If high-rise structures could be assembled this quickly, many long-standing assumptions about construction timelines suddenly appeared outdated. But speed does not determine whether a building is successful. The more important question concerns safety. Can buildings assembled this rapidly withstand earthquakes, extreme weather, and decades of use? According to the company, the answer lies in steel. Unlike concrete, steel possesses high ductility. It can absorb and redistribute forces more effectively during seismic events. Rather than cracking suddenly, steel structures can deform while maintaining overall integrity. This characteristic makes steel particularly attractive in earthquake-prone regions. Engineers also argue that factory manufacturing improves consistency. Connections can be inspected before installation. Components can be tested under controlled conditions. Defects can be identified earlier. Supporters claim this produces higher quality buildings than many traditional construction methods. The company has even promoted the idea that some of its structures could achieve exceptionally long service lives through careful maintenance and replacement of modular components. Whether those ambitious claims ultimately prove correct remains a matter of debate. But one thing is clear: the construction industry is paying attention. Because if buildings can truly be manufactured like products, the implications are enormous.
Whenever a technology appears to solve a major problem, an important question follows. If it is so effective, why isn't everyone using it already? The answer reveals the complexity behind the headlines. First, the famous 28-hour construction record often creates a misleading impression. Many people imagine a vacant site transformed into a completed building in a single day. That is not what happened. Assembly required only 28 hours, but manufacturing, engineering, logistics, transportation, inspections, and foundation work occurred beforehand. The achievement remains impressive, yet understanding the full process provides a more accurate picture. Second, modular construction faces limitations that traditional construction does not. Transporting large modules becomes increasingly difficult as buildings grow larger. Road restrictions, shipping constraints, and crane capacities all create practical challenges. What works efficiently in one location may become significantly more complicated elsewhere. Third, building regulations can slow adoption. Most construction codes were developed around traditional methods. Approval processes often require extensive testing and certification before new systems can be widely implemented. Governments naturally prioritize safety, especially when large numbers of people will occupy these structures. Then there is the issue of public perception. Many people still associate prefabricated buildings with low-quality housing projects from previous decades. Modern modular systems are dramatically more advanced, but changing public opinion takes time.
the architecture question also remains important. Cities are not simply collections of structures. They are places where people live, work, and build communities. Critics argue that excessive standardization could create environments that feel repetitive and impersonal. Supporters respond that modular systems can still produce diverse designs while improving efficiency. The debate continues. Meanwhile, another technology is beginning to emerge alongside modular construction: three-dimensional printing housing. Instead of manufacturing modules inside factories, giant printers create walls layer by layer using specially designed materials. The process reduces waste, automation increases, construction times potentially shrink even further. Several companies have already demonstrated houses using large-scale printing systems, yet the technology remains in its early stages. Questions regarding durability, regulation, scalability, and long-term maintenance continue to be studied. For now, neither modular construction nor 3D printing appears ready to completely replace conventional building methods. But that may not be the point. The real significance lies elsewhere. For more than a century, construction has largely occurred in the same place, the construction site itself. These technologies challenge that assumption. They suggest that much of the process can be relocated to controlled manufacturing environments. And once construction becomes manufacturing, entirely new possibilities begin to emerge. Faster production, better quality control, reduced waste, improved worker safety, more predictable timelines. The transformation may not happen overnight, but it has already begun.
A 57-story tower assembled in 19 days. A 10-story building completed in less than 29 hours. At first, those numbers sound almost unbelievable. Yet behind the headlines is a much larger story. This is not simply about building faster. It is about changing where construction happens. For generations, cities have been built in open-air construction sites, filled with concrete trucks, scaffolding, and thousands of workers. Today, some engineers believe the future may look very different. Factories could manufacture buildings the same way they manufacture cars, aircraft, and industrial equipment. Whether that vision ultimately succeeds remains uncertain. But one thing is already clear: the race to reinvent construction has begun. And somewhere inside giant factories across China, the cities of tomorrow may already be moving down the production line.